this video, we're going to talk about the inverse of a relation and what the idea of inverse means. We're not going to yet talk specifically about an inverse function other than to look at the inverse relation and see if that represents a function. So, and if so, we're going to talk about its domain and range. So what happens when we find an inverse is that we let the inputs become the outputs and the outputs become the inputs. Let's go ahead and let me actually throw this whiteboard up over here to help us. So we've got a domain originally of 0, -2, -4, and -6. We've got a range originally of 1, 2, 3, 4, and we have a mapping originally that looks like this, where this is our domain and this is our range. And I want to switch it now so that my old domain is my new range. And my old range is my new domain. And I want all the arrows to go the opposite way. So instead of 0 mapping to 1, I want 1 to map to 0. Instead of -2 mapping to 2, I want 2 to map to -2. And so on. This can only happen if there is a uniqueness in the relationship here where every x goes to only one y and every y goes to only one x. Then I have this idea of what's called a one-to-one function is what I have just drawn, one-to-one function. And a one-to-one function has a inverse function, which I just mapped out here. So the new set of ordered pairs for the inverse is going to be 1, 0, 2, -2, 3, -4, and 4, 6. And that set of ordered pairs is going to represent my inverse function. So if this function here were called, if this relationship here were called f, this relationship here would be called f inverse. And that looks like an exponent to the -1, but it's really the inverse operator in math. And that is what we mean when we talk about an inverse function. And so the domain, this is going to be my new domain of my inverse function, and I represent that as domain, and I put a little inverse symbol on it so that you know that it's the domain of the inverse, and this is my range of my inverse. But my domain of my inverse function, here I do it like this actually. Domain of my inverse function, range of my inverse function. So my domain of my inverse function is equal to my range of my original function, and my range of my inverse function is equal to my domain of my original function. X's and Y's, if you want to think in terms of X and Y's, they switch places. All right, let's see if we can do a couple more problems here. I'm just going to do 1 through 4 in this video, and then we'll come back and we'll do the rest of those where we actually algebraically find an inverse. We'll do that in the next video. So let's look now at the next one. We're going to just switch all of our X's and Y's here. So it's going to become -2, -6, 6, 2, -1, 3, and 1, 3 will be my new inverse function for number 2. And its domain of that inverse function is going to be -2, 6, -1, 1. And the range of that inverse function is going to be -6 to 3. This is a -3, excuse me, -3 and 3. Okay. So got number 3 here. Again, we're just going to switch the x and y in the ordered pairs. So it becomes 4, -3, 5, -1, 2, 0, 6, 2, 7, 5. And my domain of my inverse function is going to be 4, 5, 2, 6, 7. My range of my inverse function is going to be -3, -1, 0, 2, and 5. And number 4, the reason that it's different is that it doesn't tell us right away whether the inverse is going to represent a function. It doesn't say like find the inverse function, which assumes that there is an inverse function. We need to determine if we switch the x and y's, if that relation actually represents a function before we call it an inverse function. So do I see any of the x values repeated in this new relation? I do not. So this is function because the original one was a function. This inverse is now a function. So this is an inverse function, and its domain is going to be 3, 4, 5, 6, and its range is going to be 6, 9, 7, 5. One of the other ways in which we determine if a function is one-to-one and has an inverse is we use something called the horizontal line test. I'm just going to use a function like y equals the square root, not the square root, the absolute value of x. That is, any even function would do here, or any function that's not going to pass the horizontal line test. It's going to pass the vertical line test, but for the same y value, there's more than one x value, so this would not be one-to-one. Not one-to-one. And if it's not one-to-one, that means that it has no inverse. For it to be one-to-one, it would have to, for instance, let's say y equals x. Be the easiest one to show here. It's going to have to pass the vertical line test, and it's going to have to pass the horizontal line test, where every x has only one y and every y only has one x. X cubed would have also worked, because this right here, this horizontal line only touches 0, 0. However, not every cubic function is going to work, because if the cubic function goes like this and is more stretched out, then there are going to be some y values that have multiple x values. All right. That's it for this video about the idea of the inverse of a function and a one-to-one function. And next time we're going to find the inverse of a function analytically. See you next time.